Good morning, dear friends. Myself, Dr. Chandrakanta here, MG College, Malegaon. So today we have considered this fourth chapter of second sem of analytical chemistry. The name is chromatographic techniques. So in this technique we have considered two techniques, that is paper and thin layer chromatography. So what is this chromatography? So chromatography was invented by Russian botanist. Name is Mikhail Tisvet in 1906. He used this technique to separate various plant pigment by passing solution of them through glass column packed with a finely divided calcium carbonate. So this calcium carbonate is filled in this glass column like that of burette, and in that burette packed with calcium carbonate they fill this solution of plant pigment. The separate species appeared at a color band. See, the separated species appear at a color band on the column. So on this calcium carbonate column there is a different colors, which account for the name he selected for the method, that is a Greek word chroma. Chroma means color and graphene means to write. So that is a color writing. So this chromatography Greek word, we have that meaning as a color writing. So what is actually chromatography? It is an analytical technique for separation, identification and purification of compound of mixture. IPC definition of chromatography. This chromatography is a physical method of separation in which component distributed into two phases. So that component we have to be separated, identified, is distributed into two phases. One of the phase is stationary phase and that other phase is a mobile phase, and that mobile phase is move in a definite direction. So first is a paper chromatography. So in this technique in which the analysis of unknown substance, this unknown substance is analyzed by paper chromatography and it's carried out by flow of solvent on a specially designed filter paper. So that paper is specially designed for this chromatography. It's called as a paper chromatography. It is a kind of partition chromatography. What is the principle behind this? It is a type of liquid partition chromatography. See, so in these two liquids are there, and in these two liquid this component unknown substances get distributed. So it is a partition chromatography in which the separation is based on difference in distribution, that is solubility of a solid into these two liquids. So that solid is distributed, that is soluble in this two liquid differently, and thus we get this separation or identification. The solid which are more soluble in a stationary phase move in slowly. See, liquid which is, we count it as a stationary phase. If it is more soluble in stationary phase, it moves slowly, and if the substance is more soluble in mobile phase, it moves faster. Thus the different solvent move at different rate and appear at a spot at different places. Here the stationary phase is water and mobile phase is a mixture of one or more organic solvent. This organic solvent, water. This filter paper is used as a stationary support. So it is a support for the stationary liquid phase. So this liquid is not stand up. See, liquid उभं राहू शकत नाही किंवा सपोर्ट देऊ शकत नाही. So for this liquid we have this paper as a solid support, and this solid support we have this stationary liquid phase. This cellulose fibrous, the cellulose fiber of filter papers are hydrophilic, that is water loving, that is having the affinity towards water, and thus the cellulose fiber of this paper having the affinity or adsorb water molecule. So the thin coat of water adsorb on the cellulose fiber, which act as a stationary liquid phase, and this mobile phase move over the stationary phase by the capillary action. So here this paper is only solid support. Next slide. The steps in this paper chromatography. What is the first step? Application of sample on paper. Second, saturation of tank on or jar. So we either use tank or jar. Development of chromatogram. Location of spot. Identification of component and measurement of RF value. So first, application of sample on paper. So this strip of Wattmann filter paper. So this is the one kind of filter paper specially designed for chromatography. So this strip of Wattmann filter paper 14 into 30 centimeter length or 10 to 15 centimeter width is taken. A line is drawn with the help of pencil at about 2 to 3 centimeter from the bottom of paper. A small quantity of mixture, that is a sample, is dissolved in a minimum quantity of volatile solvent. So we make a saturated solution of this unknown substance or sample in volatile solvent and we spot on this baseline. See, this sample solution is spotted on a line which is with the help of micropipette or capillary tubing as shown in figure. So we see in next figure, the spot must be made as small as possible. So this spotting is very sharp, very small for maximum separation and minimum spreading. So this spot must be very small for maximum separation and minimum spreading. The spreading पसरला नहीं पाहिजे spot must be at a particular point only, concentrated particular point. So this is the diagram. So this diagram is for two-dimensional paper chromatography. So this is the baseline 2 to 3 centimeter from the filter paper. So this is the filter paper. The spotting of sample on this filter paper by using micropipette or by capillary. Then this paper chromatogram setup. So this is the setup. So we have this developing solvent inside the tank. This tank is saturated by covering with lead. So this is a paper support and this is the tank which covered with lead. Next, this is the ascending time of chromatography. This development of or separation of sample in ascending order. So this mobile phase move in upward direction against the gravity. So second type is the descending type of chromatography. This development is opposite to that of ascending. So this paper is hang vertically, spotting is carried out at the top of baseline. So baseline we mark from top side 2 to 6 centimeter from the top side, and this tub is used for filling of solvent, organic solvent, and that organic solvent move in this direction towards the gravity force. So there is a acting of gravitational force on this organic solvent. So this is a descending type development. So what is the two-dimensional? See, so in first dimension, two-dimensional, we spot this direction. So filter paper is like this. Then same filter paper after this separation is carried out, we till this filter paper. So filter paper फिरवायचा है. So like this. See, this is the AB, CD. So we filled this as this AB side goes in upward direction, CD side goes in backward direction. Bottom side again we around the solvent for maximum separation of the spot. So that is called as a two-dimensional paper chromatography. This flow of solvent in AB direction, in this case flow of solvent is from DA direction, and we get a maximum separation of spot. So it is a two-dimensional paper chromatography. Second point is saturation of tank or jar. So before immersing the filter paper or that Wattmann filter paper into the jar, it should be saturated by vapors of mobile liquid that we have to taken in jar. So tank saturated झाला पाहिजे वेपर्सनी. वेपर्स म्हणजे gaseous phase मध्ये. So that is a volatile liquid we cover with lead. So the tank is get saturated. During the process, the jar must be firm close from equilibrium between the liquid. Development in solvent. That solvent liquid is a developing solvent. This moving on the paper and vapors in the jar. So there is equilibrium between that liquid vapor which is present in jar and as well as on paper. Next point is development of chromatogram. The paper is placed in a jar with its end dipping in a developing solvent as shown in figure. So पेपरचा जो एंड आहे ते सॉल्व्हेंटमध्ये डीप झाला पाहिजे, डेव्हलपिंग सॉल्व्हेंटमध्ये किंवा ऑर्गॅनिक सॉल्व्हेंटमध्ये. So there are two type of development. Just now we say ascending development and descending development. Just now we see in figure. So this is the ascending development. So this developing solvent move in upward direction. This solvent, developing solvent, which is move in upward direction. The solvent move against the gravitational force, on the paper by capillary action as shown in this figure. So this is the lead This is the tank. In this tank we have this organic solvent or developing solvent which is get saturated in this tank. Then we insert the paper with spotting. This is a solvent spot, and this origin or baseline. So this paper is deep in developing solvent, and the solvent move in upward direction against the gravitational force. That is called as a ascending development, ascending order. Opposite to that, descending development. So in this case what happened? The development of solvent, so this developing solvent move down by capillary action as well as pull of gravity as shown in this figure. Capillary reaction is खाली येणारच as well as this gravitational force is also acted on this gravitational solvent, and this moving up this direction, downward direction. So in this case this bottom side is a aqueous solvent, aqueous phase, and this tub is filled with the organic solvent or developing solvent, and this paper is touching to this tip, and the solvent is run from tub side to the gravitational force downward direction. This is the tank, lid, same. This tank is saturated with this developing solvent that is present in this tub. So that is the ascending development. Location of spot. After development of paper, after development of this paper, spreading of the spot, separation of spot, we identify that spot. For that we have carried out this location of spot, or we identify the spots on paper. For that we use physical method, either of this method. What is the physical method? The paper is observed under a UV lamp to locate the position of colored component. A pencil line is drawn around the spot for permanent identification. UV chamber मध्ये पाहायचं सर्कल, the color दिसेल त्याला पेन्सिलने राउंड करायचे. So that is the identification of spot or separated solvent mixture or separation of that spot. Second method is chemical method. The colorless compounds are converted into color compound by reaction with chemical reagent. The chemical वापरून जे स्पॉट आहे त्याच्यावर स्प्रे करून त्याची रिॲक्शन करून आपल्याला ते स्पॉट ग्लो करायचे इन द फॉर्म ऑफ कलर स्पॉट. A chemical can be in the form of gas, liquid or solid, but generally liquids and solids are used. The solid like potassium chromate and liquid like water, ethanol, methyl or tertiary butyl alcohols are used. For identification of metal ion which is present in second group, for that we use this H2S gas. So this gas type of material is used. This H2S gas is used for identification of metal ion spot. For identification of this amino acid, identify by spraying this ninhydrin solution on that paper. When this ninhydrin spray on this paper, this amino acid ninhydrin react and which gives the blue or purple color. Last is the identification of compound. So for that, the result of chromatography separations are expressed in the form of RF value. What is this RF? This RF is a short form of retardation factor. So this R for retardation, F for factor. So this retardation factor. What is that retardation factor? This RF is defined as a ratio of distance traveled by the given substance from the origin to the distance traveled by the moving solvent. See, this RF value is calculated, this retardation factor is calculated as distance traveled by the substance. That spot, it's move in paper from baseline, that distance. The second is a distance traveled by the solvent. The solvent is again move from baseline to that paper, whatever the maximum distance. And we know this solvent move maximum than the substance, or sometimes they are equal. If they are equal, distance are equal, this RF is equal to 1. But it will not happen generally. This solvent move in slightly greater portion on paper than the substance, and the substance distance is less than the solvent distance, and this RF value is always less than 1. This RF value is characteristic properties of substance like melting point and the boiling point. So similar to, melting point and boiling point of substance are fixed, that are the physical constant. So similar way, this RF value is also the characteristic property of particular solute in particular solvent. This RF value is used for the qualitative detection of the separated compound. Application of paper chromatography. What is the application? So it is used for the separation of organic as well as inorganic substances. It is used for the separation of amino acid, also very small amount of substance. See, very small amount of substances get separated by using this paper chromatography. Two-dimensional chromatography is used for separation of complex mixture such as protein hydrolysis. So that two-dimensional. Same paper we use in run two ways, two direction. Very small amount of substance is used for separation. Also used in analysis of mixtures of sugar. Modified cellulose paper can be used for various techniques of chromatography by changing its chemical structure. For example, this paper can be sprayed with alumina or silica gel or resins, etc., and this can be used for separation of various substances. So this is about paper chromatography. The next point is a thin layer chromatography, that is TLC, we consider in our next lecture. Thank you dear friends watching this video. Continuously study this paper, that is analytical chemistry for second sem. Thank you.